Next topic is project crashing. What's project crashing? Project crashing means shortening or expediting some activities within a project to reduce overall project completion time. In the previous part, we looked at the example of house building. You had a tenant who's moving in 12 months. Your project manager says there's only a 15% of chance of completing this project in 12 months. So in that case, what can you do? You try to find ways to expedite the project. To expedite the project, you need more resources, you need more people, and that will cost you more money. So your question is, which activities should you crash by how long in order to finish this project on time at the least possible cost? So I want to take this example and show you how to crash this project at the least possible cost. In this project, we have 5 activities. We want to reduce the project's duration by 3 weeks with the least possible cost. We are given the normal duration and we are given the maximum duration. So for example, we can reduce A's duration by 2 weeks at most. And we are given the crash cost per week. So to crash A's duration by 1 week, you need to spend $200. 2 weeks, 200 times 12, 400. So this is the crash cost per week. Now, using this information, which activities should it crash? So we are given this activity on node network. So first, what's the duration of the entire project? Let's find all the sequences from start to finish. We have this AC, and we have this B, D, and E. And what's the length of AC? 6 plus 7, 13. What's the length of BDE? 7 plus 6 plus 12, 2, 15 weeks, months. Now, what's the project's completion time? Project's completion time is the length of the critical path, which is 15. Now, if you want to crash this project by 1 week, which activity would you crash? Your answer is E. Why? So, for example, if you crash A, what happens? The length of this activity will be reduced to 12. So the critical path will still be B, E, D, and E. So the project's completion time is still 15 because the project's completion time is not affected by non-critical activities. Now, if you crash C, again, the length of this will be 12 and the critical path will be still BDE, so the project's completion time is still 15. Now, next, if you crash B, then the length of this will become 14. So this becomes the critical path and the project's completion time becomes 14. So we are crashing the project's completion time. And the same thing happens when we crash D or E. So we have, what lesson can we learn from this? To crash a project, you need to crash a critical activity. A project's completion time is not affected by the non-critical activities. So we have 3 options, B and D and E, and which one should it crash? Since we want to choose the least expensive option, you can look at the cost of B and D and E. And the least expensive option is E. So E, because E is on the critical path, and we crash an activity not, if we crash an activity not on the critical path, the duration remains the same. So let's use a table like this. You have two sequences, AC and BDE, and the length is 13 and 15. And this was the critical path. And you want to crash E, then the length of this becomes, it's still 13, and this becomes 14. And this is the critical path and the project's completion time. Now, next, if you want to crash this project by one more week, which activity should it crash? Again, we need to crash a critical activity. So we need to choose B or D or E. Now, can we crash E one more time? No, its maximum reduction is 1. We already crashed it by 1 week, so we can't crash it anymore. So we are left with B and D. Between B and D, which one is less expensive? B. So we're going to crash B. So if you crash B, the first one stays at 13 and the second one becomes 13. So we have a tie. Both of these are critical path, and the completion time of the entire project is 13. Next, if you want to crash this project by one more week, which activity should it crash? Now we have two critical activities, AC and BDE. And now you have to crash both of them, because if you crash just one of them, then, for example, the first one, then the first one becomes 12, and the second one becomes 13, then this becomes the critical path, and the project completion time is still 13. So if you crash just one of them, the project completion time remains the same. So to crash the project's completion time, we need to crash both of them. We need to make both of them 12. So between A and C, which one should it crash? You need to crash A because this is less expensive. And between B and D, which one should it crash? We need to crash B. Yeah. So our answer becomes crash E by 1 week, and B by 2 weeks, and A by 1 week. So here are the steps to follow. 1, identify the critical activities. 2, select the critical activity that can be still crashed and has the least expensive cost per period. 3, if there is more than one critical path, consider all the critical paths and crash one activity from each of them.